Okay, hi and welcome to a section of video notes which cover in our book from 3.1 to 3.3. So we're going to call them inequality basics. What are the basics then of inequalities that we're speaking of? One, let's talk about what a solution is to an inequality. Two, let's see what it looks like by graphing it and kind of understanding what it means to graph an inequality. And three, finally in our examples, we'll start looking at some of the basic solving properties as we look at inequalities versus really linear functions. So what is then officially an inequality? An inequality is a mathematical sentence that compares the values of two expressions using an inequality symbol. You've seen these, you've used these. Those are less than and greater than signs. You should be familiar with them, but let's just review just to kind of make sure. And one of the things that I've noticed in reviewing what an inequality is that some kids forget which one's which. And if we have them as standalone, looking at this blue one that I've identified here between A and B, this is a less than sign. Because, and I'll just draw it out, the pointy side, or the narrow side, whatever you want to call it, the non-alligator side, if you will, is the side that is pointing to the left. So we always read from left to right, so when we say the pointy side, that means less than. And in that symbol, wherever we see it, like this, is always less than. Which would come to say, if you see the open side in any fashion and written in any which way, if we're just interpreting it, means that's a greater than sign. And of course, you know what equal is. If we include equals with it, or an equality statement, it means that this less than sign has an equal sign underneath it, meaning that it's also equal to. So it's greater than or less than and or equal to in our scenario. So there's a greater than or equal to as well. And of course, that means a null set, meaning not equal to. So now that we kind of have an understanding of how to read the symbols, let's talk about what it means to be a solution of it. So in a solution then for an inequality, it's any number that makes the inequality true. Well, that's the same as we talked about for linears, is if we plug in a value into our linear equation, that or equality statement, that it makes a true statement, meaning that 4 equals 4 in some set. Well, now what we're going to be dealing with is that 4 has to be less than or equal to 5, and that statement is true. What this means to you is that there are more than one solution, where in many times in linears, there's usually one that we like to deal with. Now, there's many cases that we explore that don't have one, but a lot of times we explore that there is one in linear. So we get used to seeing x equals 5 or x equals some value. In that case, there's usually one that we like to talk about. Well, with inequalities, there's definitely more. All right, let's do a quick example. So here is an inequality for us. X, or what I like to often refer to as the solutions, and I like to make that a verbal change because then it helps explain what it should look like and it helps explain what I should do. So the solutions then are less than or equal to 7. What I'm seeing then is any value, if I look at 7 as a boundary, meaning it's the point at which it decides where the solutions are or are not, it means that this boundary, all of my values, all of my solutions are less than, right, or equal to 7. So anything that's less than that is going to be a solution. Well, what's that look like? Well, let's plug in 9, or we could even write x equals 9, because that's what we're going to do, is we're going to replace it for x, right? So we're going to end up with the statement that 9 is less than or equal to 7. Is that a true statement? If it is, it's a solution. If it's not, which it isn't, it's not a solution. Okay? Again, let's do the same thing here with -1, or x equals -1, same thing. And let's go ahead and then see if this is a true statement as well. So I'm going to plug -1 is less than or equal to 7. And is that a true statement? Yeah, -1 is less than 7. That is true, so this is a solution. Okay, let's check one more, 14/2. Yeah, that is a fraction that can be reduced, but let's at least plug it in first. So is 14/2 less than or equal to 7? Well, let's transform it so it looks a little more clear. Is 7 less than 7? No, 7 is 7. So, but this, with the equality statement, makes this true. So it means that the solution is the boundary in this case. Moving along, we're going to go ahead and attempt to graph here. So let's take a look at this example. We're going to graph this very similar to what we had up there, but we're leaving this open. There isn't a clear solution. I'm not asking you to find what C is, but let's graph it and see what all the possible solutions are. So looking at this, I'm going to use this as my boundary. I'm going to identify it on the graph. So here's our number line, because we're dealing with one variable, and I've got -2 as my boundary. So I'm going to go to -2, and I'm going to circle it in for now. Okay. Now I'm going to interpret the inequality symbol. Okay. So, and I'm going to say it in terms of my solutions. The solutions are greater than -2. That should mean, as you say it, the solutions are greater than -2, that we're headed to the right here, right? The solutions greater than -2 are going to be to the right side. The other thing we have to interpret is this boundary included in the solution? Does it have an equal sign? And it doesn't. So since it doesn't, we're going to leave this as an open circle. It should not be filled in. If it was filled in, then there would have an equal sign. So all of the solutions, meaning every value on the right side, is a solution to that inequality. All right, thanks for watching. Make sure that you check out the example videos, and there'll be a few more that you can see here that I'm going to do.